Well, welcome to this class discussion on artificial intelligence. I'm Larry Rudner. I've been involved with computers quite a while. Got fascinated by the topic of artificial intelligence. And as I read, I said, I've been involved in this field for quite a while. I developed some of the first software for automated essay scoring, where we basically trained a computer based on typically 400 essays, and then used that to score essays as part of the GMAT exam. So as I've read more, it became an interesting topic. What I'd like to do is first start off by go around the room and then around the gallery, have you all introduce yourself, perhaps tell us why you're here, and then our special attendees, Mike, Eva, Jim, and Bruce, Jim, please tell us a little bit about the topic you're going to be talking about next week. So with that, I'm going to turn it over to you.
Yeah, I'm Jim Scoggins, and retired from the intelligence community. So the topic I'm going to be talking about is artificial intelligence and how it's used for intelligence analysis in today's environment. Fascinating subject. It's an evolving field. It's one of the fastest growth fields, I think, probably right now. So it's one thing I'm really interested in the class.
Bob DeClario. I'm recently retired from practicing medicine.
I'm Bruce Jones, retired hospital administrator and healthcare executive, and I, for 30 or 40 years, put computer systems into hospitals. And we'll talk about AI in the healthcare field.
Great.
I'm Susan Carroll. My first introduction to artificial intelligence was Watson. Remember Watson? And that really sparked my interest.
Was that Watson on Jeopardy?
Jeopardy, yeah.
Okay.
And most recently, I read Kazuo Ishiguro's latest book, Clara and the Sun. And Clara, it takes place sometime in the future. Clara is an artificial friend that parents purchase as companions for their lifted children. So it's fascinating. And then I've just explored and researched and have had a wonderful time. So thank you for doing this.
Yeah, name's Lee Young. I'm retired, of course, as a military a bunch of years, primarily intelligence, and then defense contractor for a number of years, both radar and target warfare systems.
I'm Debbie Mandich. I am a retired high school teacher of Spanish, English, and ESL, and I just need to know more about this.
I'm Steve Kravchik. I'm a retired professor at Emory University and taught religious studies, and in the last decade or so, the intersection of technology and religion.
And I'm Carol Smith, retired from banking, and this is our first foray into the Chesapeake Forum, and artificial intelligence being an interesting subject, thought it was a good base. Cheers.
And I'm Lynn Randall. I use in my field, we use artificial intelligence in market research and data analysis, segmentation, social media. We'll talk a lot about different things like that.
We had two people walk in the room. Let us put you on the spot. Tell us who you are.
Sure.
Why you're here.
My name is Paul Sharp. I have absolutely no use of artificial intelligence in any of the work I've ever done.
So you think? Well, hold on.
But big data knows you.
Oh yeah, they know me, but I don't know them. My background is marketing, but for home builders.
I'm Peggy Sharp, and design and architecture is my forte, and I don't use AI. If you're interested.
Oh,
Yes.
yes. Absolutely.
And I'll call the people out in the gallery. Bob?
My name is Bob Feldhune. I retired from the federal government. I don't know very much about artificial intelligence. I think the only way that I use it is when I use it on my Google Maps to get from one place to another. But other than that, I thought I'd listen and learn more about artificial intelligence.
Sarah?
My name is Sarah Gavian. I'm an economist. I'm working a lot, had worked a lot. I've recently retired in agricultural economics, focused on food insecurity in remote areas, which is now, as you're all watching the news, these issues of immigrants and food insecurity, but looking at areas like Sudan and the like, and in Yemen, and trying to figure out, often using AI and other using remote sensing data along with intelligence to try to figure out where there are people moving around and needing food. I also wear a different hat. I am very involved in democratic politics. It could be any kind of politics, and I'm fascinated from the marketing perspective of the use of AI in shaping opinions and also targeting voters and with different kinds of messages. Thank you.
Eva?
I'm Eva Smorzanik, and I apologize I'm not there. I didn't have access to my car today, but I will join you next week. I'm a retired, everybody in this room is retired, otherwise we'd be at work right now, right? I'm a retired diagnostic and interventional radiologist, and I would say that AI has affected my life, mostly in good ways. I think AI in certainly the diagnostic end of radiology is still in its infancy. And what's gone on in radiology, which I'll be curious to hear if other industries have been affected this way, is that a lot of it is industry driven and driven by, we have a gadget, you figure out how to use it, rather than we have a need, you figure out how to solve this problem. And that's it.
That's a good summary for the entire course, I think. Norm? You're muted.
No, it's not.
You don't have audio.
Can you hear me now?
Yes.
You okay now?
Yep, we can hear you.
Okay, I'm Norm Bell. Trying to work on different screens here, so excuse me. I'll get it straightened out in a minute. I worked 45 years in the chemical industry. I am a chemical engineer by training, but spent 90+% of that time on the human side of things. One of my hobbies is photography, and I am deeply involved with AI in the photography work that I do right now. So, but it's all behind the computer. I don't know what I have no knowledge of it. So.
Very good. Ron?
Hi, I'm Ron Rothman, also retired from an International Patient Safety Research Institute. I've watched and listened to many presentations about how wonderful systems were going to be, and rarely saw them fully realize their promise. So I'm kind of sorting out in my own mind what how AI is different, or maybe it won't be.
Very good. Mike?
My name is Mike Davis, retired from 36 years working for the Navy in submarine acquisition. Submarine design was just at the point of implementing certain AI concepts at the time I retired. I then became a consultant and in IT for Dell Computers, and also working with SAP, which is a massive enterprise management programs. And I'm just interested in computers and artificial intelligence and how they're changing our world.
It's quite a educated group we have here. This should be a lot of fun. All right, let me get this to work. I'm going to take my glasses on and off. You'll have to bear with me with that. The structure of the course is we're going to start off initially with a little bit of some very impressive applications, and then a little warning by somebody well known to everybody. Then we're going to get into the forms of the AI, how it's evolved. The first systems were expert systems. That's progressed. For each form of AI, I'm going to basically present how it works, the logic behind it. Sometimes I might get a little too detailed, but bear with me. Then afterwards, I'm going to ask all of you, what limitations do you see here? Not for applications, but what's wrong with this? Or will this solve all of our intelligence problems, things like that. Then we're going to get into the promise and perils of AI. The promise and perils are going to be discussions. Some of you are going to be presenting. Then I have a bunch of clips, some of which I view as downright scary applications of AI. It's my hope that you leave with a good respect for what AI can be and what AI frighteningly can be. In other words, the positive and the negative. We're witnessing the birth of AI tools. They're constantly evolving. And we'll see some of that evolution. But next year, there'll be some new advances that are beyond this. But my hope is that you'll have a basic understanding that you can appreciate and evaluate the next evolution of AI. I have to click over here, don't I? I'll click this there.
Now, it's a pleasure to be here in Las Vegas to present to you. Now, I get invited to do keynotes across the globe. And while it's easy for me to be here in Las Vegas, it isn't always easy for me to travel across the world. And even when I do, I can't always speak the local language. Well, what if neither language nor distance mattered for me to deliver a fantastic keynote? What if technology could help me be anywhere I needed to be and speak any language I wanted? Well, it can. We are bringing together the power of mixed reality and Azure AI services to create a truly game-changing experience. What you're about to see is an exact hologram of me wearing the same outfit that we recently captured at a mixed reality studio. And I don't speak Japanese, but what if I wanted to deliver my keynote in Japanese? Using Azure AI technology, I can translate my English into Japanese and train it to sound exactly like me, the same voice tones, those same inflections. Now, we brought this together, my hologram and Azure AI, to show you what's possible. So first, I'm going to put on my HoloLens 2 here, and then we'll flip in the room to the special camera so you can see exactly what I'm seeing. Let's get started. First, let me introduce you to Mini-Me. There she is, my perfect holograph. And thanks to the power of HoloLens 2, she just floats right with me. I'm literally holding my hologram, so natural. Now she's a little small to do a keynote. So let's get her up so she can do full-size Japanese keynote. Render keynote.
ホログラムになることには本当に驚くべきことがあります。私たちは最新の複合現実キャプチャ技術を使用し、私のホログラムを
Now, as you can see, this is mind-blowing technology. And what you just saw was my life-size hologram, my exact replica, rendered here in real time, speaking Japanese with my unique voice signature. To do this, we use mixed reality technology to create my hologram and render it here live. Then we use Azure speech-to-text capability and English transcription to get my speech. Then use Azure Translate to get the speech into Japanese. And finally, applied neural text-to-speech technology so it sounded exactly like me, just speaking Japanese. And the most amazing part? All of these technologies exist today. The future
is now. Yes.
Now, it's a pleasure to be here in Las Vegas.
Now, that's one point of view. That's truly amazing. Somebody else should recognize. He has some views as well.
I'm really quite close to, very close to the cutting edge in AI, and it scares the hell out of me. It's capable of vastly more than almost anyone knows, and the rate of improvement is exponential. You can see this in things like AlphaGo, which went from, in the span of maybe 6 to 9 months, it went from being unable to beat even a reasonably good Go player to then beating the European World Champion, who was ranked 600, then beating Lisa Doll 4-5, who had been world champion for many years, then beating the current world champion.
That's not.
So I've lost the audio.
Eva, have you lost them? I see Eva.
I see you now, and I've lost them. I can see that I think our connection is gone.
So I think it's really on their end, correct?
Yeah.
Yeah, this is Mike Davis. I've also lost the video and audio from them. So I'd say it's on their side.
All right.
Someone send them a chat.
They probably know. Oh, if they're not, if their screen, they got the whole screen thing showing, right? Yeah, we'll chat them.
I don't think I have his phone number. He didn't share that, right?
Well, but just do a chat from.
So I just did. Are you guys getting it? I spelled online wrong, but.
Yeah, I see it. I see it.
Probably we can raise hands. Can we scream or jump up and down? I'm gonna try to jump up and down.
I think he's realizing it right now.
It's funny, like all the sophisticated AI, and we just got a Zoom problem. I don't know any other way to get his attention.
No, I think they're working on it. Here comes Lynn, probably.
All right, you guys can hear us now, right? And
Yes.
we can go ahead and share
Right.
the stream to you. Oop.
We lost you right around when Elon was saying how worried he was about the chess. So the chess, the guy who was the Go game or whatever.
Elon Musk.
And for some reason.
Oh, I need to share my screen.
But we might, just 1 second, you guys. I think you're going to have to get out. Do you want me to do it?
Now your screen showing up.
Yeah, the screen's showing up. Now we'll go back into. Okay.
Ah,
Okay, but so wait, so just 1 second. Can you guys see the content yet? It's not, is it showing up?
Yep.
Perfect.
Yes.
Okay. Well, thanks for bearing with us. You're one big happy experiment these days.
I'm really quite close to, I'm very close to the cutting edge in AI, and it scares the hell out of me. It's capable of vastly more than almost anyone knows, and the rate of improvement is exponential. You can see this in things like AlphaGo, which went from, in the span of maybe 6 to 9 months, it went from being unable to beat even a reasonably good Go player to then beating the European world champion, who was ranked 600, then beating Lee Sedol 4-5, who had been world champion for many years, then beating the current world champion, then beating everyone while playing simultaneously. Then there was AlphaZero, which crushed AlphaGo 100-0. And AlphaZero just learned by playing itself, and it can play basically any game that you put the rules in for. Whatever rules you give it, it literally read the rules, play the game, and be superhuman for any game. Nobody expected that rate of improvement. If you ask those same experts who think AI is not progressing at the rate that I'm saying, I think you'll find that their predictions for things like Go and other AI advancements have their batting average is quite weak. It's not good. I'm not normally an advocate of regulation and oversight. I mean, I think one should generally err on the side of minimizing those things. But this is a case where you have a very serious danger to the public. And therefore, there needs to be a public body that has insight and then oversight to confirm that everyone is developing AI safely. This is extremely important. I think the danger of AI is much greater than the danger of nuclear warheads, by a lot. And nobody would suggest that we allow anyone to just build nuclear warheads if they want. That would be insane. And mark my words, AI is far more dangerous than nukes. Far. So why do we have no regulatory oversight? This is insane.
that's a little different point of view about the future of AI. There are those that are predicting that AI will outperform humans in every field in about 50 years. And at the same time, keep in mind the fact that 2 years ago, Gartner, a big market survey guy, identified that 79% of businesses were exploring AI. So that's our start of a background. We're defining AI here as a very, very broadly. We sometimes think of AI in terms of how the Matrix movie, but AI is simply the use of computers to help us think through things. So on the simplest level, linear regression is a form of AI. We've got data, we put it in, we're making a prediction, we find it useful. That's a simplistic version, but the simplistic encompassing definition, and the AI field uses this definition. And that's the one I put on the screen. A wide field, basically doing what humans used to do. We think in terms of image recognition, understanding natural language, writing patterns. This is all applications of AI. Now I want to look at my notes here. On many tasks, AI is going to be better than us, and that's why we would want to use it. But, and I think we've had several of you already mention, blindly accepting it may be dangerous. It may not be what we want. And that's what we're going to explore here. So we talked about what we have now, which is narrow AI, car GPS, suggesting content, that little bot in the corner when you buy things that try to help you out. Reading mammograms, that's all fairly narrow. It's a very narrow, specific task that we've asked AI to do, as opposed to Skynet and HAL, which are this basically replace human beings. They're able of broad logic, broad reasoning. There are those that question whether computers will ever get to the point of HAL and Skynet. Because what humans can do, which computers can't do, is we can generalize. We don't need to see 300 pictures of a cat to recognize a cat. Show a human being a few pictures of a cat, and they learn pretty quickly. So there's a lot of difference between humans and computers and how they interact and how we approach a problem. That said, the computer person, the AI person will say, yes, the computer does it differently, but it can do what you're doing better. So let's use something from my field, automated essay scoring. To do automated essay scoring, you typically look at the key words in an essay. And we're going to talk about this more specifically later. But it's looking at individual words. Whereas a teacher grading an essay is going to look at the gestalt, the whole picture, the flow of things, the flow of logic. The computer recognizes that the better capable students, those that get an A on the paper, tend to use one set of words, and those that get a C on the paper use simpler words. So the computer approaches the problem differently, but it has the advantage, it doesn't get tired, it doesn't get biased, it doesn't look at an essay and go, oh, I know all about that, or I've read 400 essays just like this one, I'm tired of this. The computer doesn't have those problems. The AI person will argue that the computer scoring the paper is like the average of the 400 graders that were used to train the computer system. So rather than being one person's bias, it's the average of 400, therefore it's less likely to be biased. So we're still in the world of narrow AI. Whether we're ever going to get to the world of big AI, general AI, we don't know. You brought up the example of AI in our lives. When we use GPS, it uses AI to find the optimal route. How can I get from point A to point B quickest, subject to the constraints of the road? The constraints of the road is a big set of things, speed limits, it's one-way streets, it's traffic patterns and things like that. But this is what we call an optimization problem. Talk about that. Voice recognition. In the early days, several of you will probably remember Dragon Speaking, where you had to laboriously try to train the computer on your specific voice. Siri now does a pretty good job on anybody's voice. It's kind of scary and kind of frightening. Again, this is using AI. This is kind of a form of a neural net.
Sarah has a question.
Sarah. No, she doesn't have a question.
Oh, okay.
Okay. Facial recognition. Again, this is technology that those with an iPhone 10 or 11 have. I don't have that modern of a phone. Your cell phone can recognize your picture. Now, any idea why it will not let you close your eyes for facial recognition?
Eyes.
Well, the eyes are important.
Yeah.
The eyes are important. It needs live eyes. If you have your eyes closed, you could be hacked. Somebody can take a picture of you and use that. Although there are some that have demonstrated that you can have a full-size mask and take some of these pictures, but that's beside the point. if you think about facial recognition, the way it's working, it's got a zillion measurements. How far apart are your eyes? How long is your nose? Thousands of measurements on your face. We as humans look at faces, we see differences. The computer sees a million measurements and sees and categorizes them. So a computer can use that set of measurements to recognize its face. Totally different approach. We as humans, we look at the whole thing. The computer is based on lots and lots of measurements, a ton of data.
It's interesting that it can recognize pets, because, you know, to tell you the truth, I think Labrador A looks just like Labrador B most of the time. Unless somebody puts a different colored collar on them.
Not to another Labrador.
That's true, but they can smell.
Healthcare is another big field for AI. We're fortunate to have somebody who knows a lot more than I do talking to us about it. I think it got started with mammograms and looking at the data from mammograms. That's if you're looking at the more advanced AI. There were a lot of rule-based versions of AI, where if a patient came in and had this and this and this, and if that, and if that, and if that, then you're going to make a diagnosis. So again, this is a field where it's advancing very rapidly.
So who programs it? Is, you know, in other words, like somebody in the beginning set the computer to go these 400 things and then learned, you know, which measurements to make and.
Typically, well, we're going to go through different approaches. But to answer your question, typically you have a big data set of some sort. And you set aside 70% of that data for training. Then you validate it on another 20 or 30%. But
Yeah, but I guess what I'm missing is you got this mammogram or something like that, and you pull, you know, who wrote the program that's gonna put it together to make it recognize? Like, how does it go that next step from taking the 70% of those mammograms to coming up with?
well, it started off with a database of thousands and thousands of mammograms. And the computer scientists that were developing AI use that for the training. And once that's done, then they sell systems where here's an AI system that will read mammograms.
Well, we use AI in personalized medicine as well for cancer diagnostics and care. And that, like Larry said, that's based on a huge database of information on the type of, you know, all the variables that might play into a decision that a cancer care team might have to make. But it's continually updated because every time they have a patient, it's they're logging them back into the system, and the AI is learning from any mistakes it might make and finding out, or it's learning that maybe this medication will only particularly work for X amount of time versus one that will work longer. Does that make a little more sense?
I'm missing the translation from the problem and the data to the program or whatever you want to call it, the AI that recognizes the next case. Doctor.
Well, I'll try to help, and Ava as well. You have images that are normal mammograms of a certain age, and you wrote a software program that says, whenever you see something like this in many measures, that's normal. And then the system, if it's truly intelligent, it will continue to learn that an additional view can be a normal. The margins, the density, et cetera, et cetera. And that, you know, and that can be written in software code.
So somebody has to write the software code?
Yeah, yeah, it's usually not the
At
radiologist.
the moment.
Yeah.
There are people who work doing research on systems to write their own code. But right now, yes, it's each AI application is a researcher or a group of researchers taking a data set and building intelligence on it.
And probably selling it to somebody for their use.
Right.
Yeah, and I can add to that, that the very first application, as Larry mentioned, was mammography. Because it's one organ, it's 3 different tissue densities, and most things that are bad have calcium in them. So this is a simple form of, I guess, what you call machine learning, where you just say, hey, you get a density reading that is above this, but less than this, put a little X on it. And they put a bunch of these cases in, normal cases, these cases, and then the machine does that. But because it's machine learning, and at that point, the computer, the software didn't learn from its own mistakes. So then the radiologist would get the mammogram and it had 35 X's on it. And you said, oh, this is garbage, this is garbage. And then you tweak the numbers and you change the range. And that's how you learned. Invariably, it was always a toss-up between getting handed, 35 false positives, resulting in a lot of callbacks, a lot of unnecessary biopsies, and so on, that made us very skeptical of the technology at the start. And this is an example of what I said before, which is this technology was heavily marketed by the industry to hospital administrations, to women's groups, just like breast tomography, that this is good, this will improve accuracy and blah, blah, blah. And the reality of it was not so. The systems have gotten better because now the algorithms are more complex, and now there is, I believe, some deep learning going on, but that's basically, so it required this constant interaction, even after you had the thing, to tweak it to match what your human eye would call abnormal or not abnormal.
And then the business end of it is your research and evaluating the 35 false positives that help the vendor do a better job.
We made a lot of patients miserable, right?
Yeah, but the vendor did well with that.
Great, yes.
The sale is always to the administration is that this will lower your costs. And as you saw at the beginning, it really didn't. It made this possible it is now, but.
Okay, let's talk about a few different approaches to AI. First is expert system. This is a rule-based system. At the very beginning, people thought if we can just have enough if-then statements, we can capture what somebody does, and we can make an expert system. And that was the first form of AI. Then another form came about, optimization. This is the GPS in our cars, where we set an objective goal. We want to maximize or minimize something subject to a bunch of constraints. Then it evolved into machine learning, where we take large data sets and differentiate. We have one group of normal and abnormal and what differentiates it. And that expanded to even more and more. And then reflective learning is what Elon Musk referred to, where the computer taught itself. And we're coming up. So an expert system is simply a set of rules. We can have a set of rules for playing tic-tac-toe. A set of rules might look like something like this, where depending upon one move, then we do this, and then depending upon the next move, we do that. Very rule-based. So now I'm asking you all, what do you see as the promise of this? What do you see as the limitations of this approach? In the very beginning, this was sold as the cat's meow. This is the ultimate, we're going to use computers to solve our problems.
It's only based on what you can predict. So in other words, the rules have to be perfect.
Oh, by the way, let me clarify. What I'm going to do here is I'm going to ask you all to discuss it. Then I'm going to put up my screen of what I thought of. So I'm expecting you to have things that I did not think of, which is kind of a concept here with regard to expert systems, isn't it?
So Sarah,
It's a much better.
can you hold for comments?
Sure.
I think, I'm not sure the rules have to be perfect, right? They may with the mammogram, but the learning part, like when we use random tree walks and things, you just have to, or any ANOVA, anything that the regression or econometrics techniques use, you narrow difference, right? So you just keep throwing darts at it. I mean, even 40 years ago or 30 years ago, my dissertation uses maximum likelihood techniques where you kind of just throw answers at it and then it says, does that solve the set of equations better than the last answer? So there's a lot of these techniques, right, where you can just kind of throw stuff at it and see what sticks, and in that process get down to an answer. Is that true about some of the methods?
I think that's true about the next method we're going to, one of the next methods we're going to talk about, which is basically Bayesian inference. With expert systems, I believe at the time it was strictly rules and not narrowing down. And the example I like to give, I was 10 years old. My father brought me to a science fair and had all these booths all around the place. I think this was really for college kids, but my father was a school administrator, so he took me there. And one of the booths had tic-tac-toe, and it was a rules-based expert system. And I was playing tic-tac-toe, and I won. And the guy running the booth was in total shock. Well, the reason why I won is I cheated. Okay, I knew that. The guy there didn't know that. And clearly the expert system didn't know that. So,
How do you cheat at tic-tac-toe?
well, the computer was pretty basic. I just took one of his pieces off.
I can only imagine how complicated that method would be for chess.
Yeah. So basically you're saying what I'm hearing, well,
Well, one of your limitations, in my radar world, you're limited with computer power.
Right.
When you're airborne. The combination of permutations of things you're trying to do will drive you crazy. So you have very finite boundaries to do there.
Right, so it's better for simpler problems rather than more complex problems or organized complexity where everything interacts with everything else. You know,
I have a question. Driving cars. How does AI enter into that product?
well, that's a collection of a whole lot of AI technologies. The most important is visual recognition, visual systems. Well beyond expert systems.
Right.
But there are rules that have to be built into autonomous cars. And one of the dilemmas that those that are working on autonomous cars are dealing with is what expert rules do we put in? Because the autonomous car that's programmed is going to have to deal with issues that we as humans don't. We're driving down the street and somebody jumps out in front of us and we can't stop. What do? Well, whatever your quick instinct is, and that's fully legitimate. What if the computer now has a choice? Do I kill the guy who jumped in front of me? Do I kill my passenger? Do I kill the person walking on the street? The computer's going to have to deal with that. So there will be a bunch of rules built in. At the heart of AI for autonomous vehicles, it's going to be the visual sensors. Here's my
limitation of an expert system. Any expert system is that fundamentally, if it's a robust system, there will be statements which may or may not be true, but we can't develop. We cannot figure out whether they are, and that's just inherent to the system. It's not a computer problem. It's a set theory problem. That there are certain sets which can produce truth statements which you can't evaluate as being true or false. So, I mean, as simple as the integers, that's the case. So for every expert system, there will come a point where it can't tell you what the truth value of that statement is. You have to go to another system beyond.
Basically, what I hear you saying is you can't write a rule for everything. And even, well, that's one. And I also hear you say, and I agree, that there are systems that are going to be too complex for a rule-based system. It's not very complex to be too complex.
Right.
So here's my list. And I think you guys said all of these. And I think what you were also saying is number 4 there, where there's something going on, we don't know what we can't articulate the rule, but there's maybe a rule behind it.
Or maybe a rule is lacking, which is why the information is coming back bogus.
Optimization is a whole field of study called optimization. Basically, the approach is you have a function, something you want to maximize or minimize, and you have a bunch of variables that you can change, and then you have constraints. So as we already brought up the example of the GPS, where our goal is to minimize the travel time, and the constraints are the different things on the road, and what you can vary is the route that you take. Excel comes with a very interesting optimization package. It's an add-in. I encourage you to play with it. Basically, you go to your Excel options and add it in. It's called Solver. There are advanced forms of Solver that are free. I've used them in my work to develop perfectly parallel test forms and to develop shortened versions of a test that have pretty much the same characteristics of the first test. The example that I tell people to start with in Excel is the restaurant problem. A restaurant manager wants to schedule employees. All employees must work 5 consecutive days. They need a certain amount of staff on each of the days. How do you minimize cost? That is varying by varying the schedules, how many people are at each schedule, and still meet the demand. So if you set that up, we're going down A through G of the various schedules. Those are, rather than 5 consecutive days, I picked the 2 days off. The yellow column is how many staff we're going to need for that. And we're going to change those numbers. Then the matrix that starts, can't put there. No, I can't. The matrix that goes under the days of the week, that's simply going to be the number of people in each column. So if I put a 2 in the Sunday, Monday, there'll be 2s in Tuesday, Wednesday, Thursday, Friday, Saturday. And I'm going to add that up. So the line on the bottom, yeah, the mouse doesn't show.
I think it's right there in number 1. If you need
Is
to
it
go.
showing on the screen?
Yeah.
Oh.
It's right there. So are you wanting to get out of this view so that you can make it work?
No, I'm just going to do this quickly.
Okay.
So what we're going to do is we're going to vary these numbers. That's going to increase this number. That's the number of staff days. It's a bogus data here for 40. Then 2 times 40 is 80. That's the payroll. So our goal is going to minimize the payroll. And the constraints are going to be, we don't want these numbers. These numbers must be these numbers or better. In other words, the sum of the columns have to be greater than or equal to what we have here. And if you run the program, it solves the problem, and here's the optimal schedule based on these constraints. There are examples in Solver for managing a portfolio and so forth. I highly encourage you to look at it. when you get the set of slides, you can see where the links are, where the file is. Another example, one that I use, I'm an aspiring oyster farmer. I'm preparing a crop for the spring. I have a budget of $5,000 for seed. The seed comes in different sizes. Do I want to buy small seed, which means more work, or larger seed, which means less work, but costs more? So I can put it in a solver and
I can't hear you, Paula.
I can put that in.
I know.
Is it okay if what is this?
Artificial intelligence.
Did you just lose my audio or?
No, he's talking to somebody.
She said it got cut off entirely. I understand, Simon.
You can't hear? No.
Now we, okay,
Okay, all right.
good. And the answer to this one, I set it up again. Here's my objective function. I want to maximize profits. I'm going to vary the number of seeds that I buy, different sizes. The constraint is I don't want to spend more than $5,000. And then here's my bunch of calculations. And the answer, by the way, is you buy larger seed.
And you went over.
Now, the goal was 5,000.
Right. Isn't that the?
You're right, I did.
Not by far. I'll front you the one.
No. This is the number of seed.
Oh, it is?
It's
Oh.
not the dollar amount. This is the amount of seed that I bought.
Now, where does it tell you the actual amount? Is it actually?
I probably, yeah, it is, because it's nice even numbers that I'm working with.
Oh, okay.
So, what issues do you see with regard to optimization? Limitations, issues?
Well, it takes a brainiac to figure it out.
Well, you had in your example, a limited number of variables.
Very good.
Is the most obvious thing. And a human mind could include, other variables that might not be in the model.
Types of cages you're using.
Yeah.
The way you're
Yeah.
placing them in the order or.
It's also static, that if things were in constant motion, then your variables may actually influence one another as opposed to being discrete. These are all discrete, but when they're affecting one another, then you have a different calculus working.
My thinking was that when we make decisions, they tend to be additive. Well, I want this, but now I'd have to add this component in. And I'm not sure that this would adapt to that method, which is kind of really what you said a lot better.
Here's my list. And I think it, again, iterates what you guys found. In the early days of optimization, it was limited to linear. All equations had to have a linear relationship. Now we have nonlinear models that are very effective, very good. The solver that comes with Excel is limited to linear relationships. So don't even think about sticking in an absolute value. You can't deal with that. Machine learning. And several of you will recognize this example as a Bayesian example. We asked third graders to write an essay about eagles and ecology. An essay that gets an A may talk about soaring to 10,000 feet, consuming fish, visual hunters, a bunch of different words that they would use. Whereas a C essay, rather than saying soar, would use the word fly. Rather than 10,000 feet, would say high. Rather than consume, would say eat. There are differences. And so what you can do is you set up a matrix where you've got all the words that people have ever used in your training essay. And what percentage of essays that were A's used each word. And so, again, here's an example. 40% used the words of the A essays, use the word soar, 20% of the C essays use the word soar. You do that for all the words in the essay. Computer can do that. Humans can't. Computer can do that.
Start using bigger words.
And the reality of it is the probabilities will not be this high. They'll be much less than this. And if you multiply all those probabilities, that is, you have an essay that used the word soar and you use the word consume, but didn't use the word majestic, then you would multiply it. You would do a calculation based on this observation. So in the case of a probability of it coming from an A, it would be 0.4 times 0.6 in the absence of majestic. 1 minus 0.4, 0.6. The probability of the essay coming from a C, or somebody who deserves a C, would be 0.2 times 0.3 times 1 minus 0.1. And that gives you a really tiny number. You normalize it, and you have probabilities that we humans can understand. So on these 3 words and this limited data set, the probability of an essay that uses the word soar and consume and doesn't use the word magic, 73% chance it belongs to somebody with an A, 17% belongs to somebody with a C. Okay? Mathematicians in the room, you like this?
I have a question, but more from a humanitarian point of view. What goes into this determination from background of students? For example, if the student is in a classroom where a teacher has taught students to elevate their language, that would show up on the A. If the students are in a classroom where a teacher doesn't realize the importance of that, those children would have a C. By the same token.
But are those essays still an A and a C essay?
Yeah. So, but my question is, how does this affect the person receiving the evaluation? And maybe that has nothing to do with what we're about, and that's okay if you say that.
I see what you're saying though, because that we're paying a lot more attention to that now, you know, with we're knowing that kids coming from inner city schools, for example, haven't had the opportunities, the same learning opportunities as say a kid coming from, you know, I don't know, some suburban high-ranking school. But the only way to be, you know, that's more, I would think, for a GMAT test, you would have to report this, but then I think maybe some of the universities might be applying another part of the equation as to what the school is they're coming from, or the area they're coming from.
And limitations on something like this are that it would never account for creativity. Some of our greatest writers, you know, would flunk. We saw this when there were matrix in the high school, you know, when they did something like this, I want to say with humans and criteria established, gifted and talented students might fail the essay. Think of an EE coming, you know, he's out.
Yeah, but then you also have the B student who knows that they're.
But if I might go back to Susan's concern, at least 20 years ago, teachers in Baltimore had major grade inflation. They were telling the kids that they were A students and they were C at best. And what we tried to do is implement an essay system like this, where we would give the students feedback as to where they really were. So parents can then explore and the kids can then explore. So I guess my answer to you is, yes, we're missing the creativity part, but it's very capable of identifying the difference between an A and a C student.
Right, that's absolutely obvious.
Sarah?
Along those lines, when my children were in school, let's say they're in elementary school about 15, 20 years ago, They give the rubrics, right? So one thing that's happening is you can capture this information in the scoring you actually provide your students. And so they would be very tight rules about what was an A, a B, and a C. And the teachers would teach to it. I mean, we can scream about this, but the teachers would teach to it and the kids would get graded to it. And one advantage, if you've mechanized it like this, is you've taken out any sort of personal, right? Any kind of bias that the teacher has. So we could debate what the rules were. I mean, I think you're also reacting to, is that really better writing or not? But once you clarified what the game is, that can be made clear to the participants. Right?
To be actually not that accurate. Having graded thousands of essays for 40 years, what happens is students learn to use the words that are expected. Doesn't necessarily mean they've made any sense.
You're
And,
training the students.
and that's what's going on, right, with training people to take the LSAT or the GMAT or the GRE, so that at this point, they've become less important in terms of making decisions. Because what we've discovered is that they're good at learning what to provide you rather than actually writing an interesting essay.
And schools don't really use the essays.
Yeah.
Right. That's what we did research on it. When the GMAT used to have 2 essays. I got rid of one because schools didn't want it. Schools liked the essay, not because it was an essay, because it was an independent writing sample that they knew was written by students. Whereas the letters of application, the biographies and so forth, they really didn't know who wrote them.
Yeah.
And so it had a totally different, the essays on the exam had a totally different value.
There's a famous quote by Leo Rossi who said, "Beware of classes which seduce the immature mind into believing that they understand the problem if they can describe it in polysyllables." Jargon is not insight, and vocabulary is the opiate of radicals.
I would contend that exactly the opposite of that is true. I used to read my kids' law school exams.
Right.
And I said, if this is clear enough that I can follow your argument, then it's well written.
Yes,
And
he would
that's-
agree.
That's what he got.
Yeah, and that's what Leo Rossi would agree with. Yeah.
What I presented was a bag of worms,
Worms or words?
bag of words. Sorry. Yeah. There's lots of ways of improving on it. But regardless of how you improve on it, there's still a lot of limitations.
Right.
This was supposed to bounce back. And you brought them up. Are we using the right variables when we're doing our Bayesian analysis? One example which I meant to bring up is suppose we trained our sample on kids in Montgomery County, and then we used them here. Major bias. Okay, and major bias, you'll see, is a theme throughout the failures of artificial intelligence.
By the way, that Zoom will shut off exactly at 2:30. I'll email when we get close. If anything else.
Okay. We're doing fine.
I'm just looking at 23. Fine.
Well, I got more too. I got another set of slides. But I will pick up the pace a little bit. Neural nets is what most people think of today as artificial intelligence. And the basic logic is we have what we call a neuron. And we have our observed variables, x1, x2. We apply some weights, we add a constant, and then we rescale it. So basically, the output is going to be a function of the input variables and the weights that we assign. This looks like regression right now. Okay. But what if we expand the neural net so that we have a hidden layer? So now we have our observed data, x1 and x2, and we're modeling a hidden neuron, 2 hidden neurons. And then we use those hidden neurons to get our output layer. So what we've done is we've gone from 1, 2, 3 variables, the 2 weights in the B, to now we have 2 weights for each neuron, 1, 2, 3, 4, 2 more weights, 5, 6, 2 more weights. So now we've gone to more variables. One rule in mathematics is the more variables you stick in, the likelihood of a better fit goes up. You can, so here we've used the computer to generate much more data, and we're getting better fit. So you may end up with really complex systems. For example, you can start with a data set of images of clothing. And we've got 10 different types of clothing represented in this data set. Each little square is 28 by 28 pixels. And so now we can use the ons and offs of the pixels to predict which data set, which category it's in. And we can develop a model. And if we want to develop a really fancy model, we can expand the data set even further by going 1 square outside of this. That's called a convoluted neural net. Okay, the point is we can now jump and increase the number of neurons, increase the accuracy of our test set. So we're training on the same data set. We put 30% aside, and then we're reapplying it. Statisticians in the room think of that as shrinkage. It's testing the accuracy. That's basically the logic behind neural nets. Now, if you back up, again. When we did this one neuron, I can interpret these weights. This variable is more important than that variable. Now that I go to this system, where I've got all these weights, I don't even know what these weights mean. But it works. And herein lies the big, big difference between artificial intelligence and mathematics and statistics. In statistics, we're using a model and we're predicting, does this model hold? Typically, we use the null hypothesis. Does this lead to a contradiction? But we can interpret all of our variables. Even in factor analysis, we can define what those weights are. In artificial intelligence, we don't care if we can understand the model. Does it work? Now think of Facebook and all the data it collects and what it's trying to predict. They don't care if the model makes sense. They don't care about what variables are more important than others to an extent. Does this model work? And does it only work incrementally?
So they want to know, they're going to test the model versus one model only predicted correctly 20% of the time versus one that was 80% of the time, then they determine whether it worked.
Well, Facebook would clearly want the 80%.
Well, right, I mean, that's how you're determining whether it's working, is how often it predicts correctly.
Correct. And that's the only criteria.
Because that's when we were talking about this, I was thinking about all the statistical modeling that my team will do. And I could see an application for AI to replace modeling, which is basically because that can go beyond just straight mathematical statistical equations and all that. It can go into like this, which is kind of a cool way of looking at it. I don't know.
Well, I've used optimization to solve linear equations.
Yeah.
Okay. I couldn't do the math, so I stuck it in and it computed it for me. Okay. It told me what the variables are. And again, I can interpret that. This variable is more important than that variable. Here, no way to interpret it. Now, in all fairness, there are lines of research that try to help evaluate different variables. But for the most part, no. So, what issues do you guys see with this?
Well, to Sarah's example earlier, I'm not sure that if you let AI determine, do this neural net, it's not going to take into consideration some important factors that would allow you to target certain audiences that are similar, that type of thing. Again, I'm not using technical terminology.
No, you're fine.
It seems to me if you don't have a care or have a handle on what the weights are, you're hunting for an outcome.
Right.
Yeah.
Without caring about the.
And that's, can be bad.
I'm in a hospital and I want to figure out who is going to likely benefit from the intervention. Okay, I want to screen them out. So I'll use AI and the AI says, that's a good candidate, that's a good candidate, this person's not going to survive.
So how do you determine the output? So that in this.
You model it with examples of output.
So, no, you predict the output. I mean, because
Well,
Facebook must have an output, like if they want to get you the right ad, or they want, there's different outputs that they.
Right.
Well, that's
Well, the goal is
that's
to
outcome.
predict the output, predict the outcome.
Yeah.
And you develop a model based on previous data.
Right, so the outcome is already pre-predicted.
Well, no.
So like you're.
Yes, yes, but the new novel data is most like this set of data, and therefore this is the predicted output. But our input data that we started with is a big, huge data set.
So you're going to say, I want to predict the outcome of at Y, or I want to predict the outcome of X, and that's what this would do. It's not.
I would think you'd want to use some of this, but you have an outcome and want to say what variables are most important to know to get this outcome.
Yeah, but that's not it. That's data analysis.
Yeah, and Sarah has a question.
Well, I was going to say, if you're going to the track and you use a system like this, I'm getting feedback, sorry. That sounds fine to me. But if you were going to decide in the example you just gave, who gets a treatment or not, you've got a lawsuit on your hands pretty darn fast, right? Because you can't justify, you've got no rules, right? So it looks arbitrary on the outside.
I agree fully.
And to go a step further, I've watched, I don't know if it may have been a machine learning, not neural net, but I watched data scientists take data from, happened to be the country of Niger, and throw it all in. And these guys knew nothing about agricultural economics or anything. And they could tell you certain things about like where pasture must be. So these models can be clever. They can figure some things out, but they can't tell you why. And when you come at it with a old-fashioned conceptual model, you've got positive human, back in the regression world, or could be regression through multiple lines. You've got a model in your head as a specialist that explains the world. And the amazing thing about big data is they don't seem to need that, and they seem to get these useful answers, but they don't know why. And sometimes if you want to then go the next step to spend, as you were saying there, give a service or understand something more profoundly, you can't. You don't know why.
But it seems the problem with this isn't the methodology, it's the use you use the information for. So that's a slightly different problem.
I'll accept that, except that we're basing this on data.
Right.
And that data, and we're not understanding the variables.
Right.
I would argue that it doesn't matter if it works or not. If you don't understand the data that you're putting in, you've got an issue.
Yeah.
So by your argument, you should never use a neural net.
No, I'm saying you use the neural net. The danger always is in how you apply the output that you get from that neural net. There's where the danger is. Because if you don't understand, you can get a wrong answer. But getting a series of answers is a good starting point, but it's not a good ending point.
Oh, I agree with you 100% there.
Yeah.
That's how consultants stay in business.
Yeah.
The example that I started to allude to with making decisions who's going to get treatment or not, as I understand, is certain, if a person presents with certain conditions, they're going to get treated regardless of all the other variables. So in a data set, that's a constant. That variable doesn't predict it all. So it's very likely that that very important variable will not be included in a neural net or won't have any weight in a neural net. This is under the big broad category of bias of the data. It's also not understanding what's in the data.
That black box.
That black box. The last approach I want to talk about is reinforcement learning. And this was the go. Basically, we set up a system, we give it a set of rules, and we let it try the rules. Let's just start with this.
That's now possible because of the algorithms written by Yoshua Bengio and a small group of scientists.
There are many aspects of the world which we can't explain with words. And that part of our knowledge is actually probably the majority of it. It's like the stuff we can communicate verbally is the tip of the iceberg. And so to get at the bottom of the iceberg, the solution was the computers have to acquire that knowledge by themselves from data, from examples, just like children learn, most not from their teachers, but from interacting with the world and playing around and trying things and seeing what works and what doesn't work.
This is an early demonstration. In 2013, DeepMind scientists set a machine learning program on the Atari video game Breakout. The computer was only told the goal, to win the game. After 100 games, it learned to use the bat at the bottom to hit the ball and break the bricks at the top. After 300, it could do that better than a human player. After 500 games, it came up with a creative way to win the game by digging a tunnel on the side and sending the ball around the top to break many bricks with one hit. That was deep learning.
That's the AI program.
That's now possible because of the
I hope between now and next week, you think about that last video. I personally find it frightening. We have no idea what's going on in the computer's mind. We have no way of identifying it, and it's doing something better than we can. So far, what have we discussed? We need to do artificial intelligence. You typically need lots of data, and lots of data means there's going to be bias in the data. And that is a major Achilles heel.
Isn't there less bias the more data you have?
No, not necessarily.
Depends
The
on-
more representative the data is, the less the bias.
So
But-
that's a human factor of selecting where the data comes from?
Yes, exactly. And typically, it's what data is convenient, as opposed to, oh, we're going to go out of our way to get a representative
that's so
sample.
true, yeah.
You're thinking in terms of a
I'm thinking-
researcher,
Yeah.
not in terms of developing an AI system. Computation intensive. Some of these take a week or two to program for the algorithms to chunk the data. Not that that's a major concern. You use different models, you're going to end up with different results. And again, if we're trying to develop something complex, model something complex, it may not be possible, okay, or at least not in our current capabilities. So, if you're given what I've presented, how would you go about designing a spam filter? Anybody?
I'd put a whole pile of spam emails into it.
Okay.
But the problem is that what's spam to me might not be spam to somebody else.
But there's a spam that's undeniably spam. AOL has done this as far back as 2005 or so. And it's relatively easy. But it doesn't stop the evolution of those that are spamming. I mean, it's hard to anticipate.
Now we have words that have 2 letters with space and then the rest of the words and so forth. Well, I for one have found spam filters vastly better today than they were 10 years ago.
Yeah, so when I think of spam, I'm thinking of our email and maybe even phone calls. But what's on AOL is not typically considered spam so much as it is misinformation that's purposely being sent out by bots, which is easily identified today.
Oh, you think that's easily identified?
It's pretty easily identified today because of the intelligence that you can put into the system. That's exactly what Facebook had to do, but Facebook wasn't capable of doing it until fairly recently, probably the last 6 years at the earliest, to be able to learn, have their systems learn it. And it's part of there's a learning function involved that can create bias.
But 90% of all emails are spam.
But what percentage of that do you now see?
I see a lot of it still.
Yeah, but are you mistaking are you calling spam when you get emails from places that you've done business with? Or
No, but I do call it spam if I'm getting unsolicited requests or ads or whatever. That's spam.
Yeah.
And there's a lot of that.
And it's not being.
And it's not necessarily misinformation, and it's not necessarily.
But that's email.
Yeah.
Where misinformation is talking about social media. Yeah. But the emails, I get a lot of that too, and I spend a lot of time going.
Yeah.
Well, or more effectively, I tell it to. I treat it out as treat it as spam and call it out.
And that gradually diminishes it, but you'll never get rid of it.
Okay, recap.
And I don't know why I said not all AI requires data. To go back and revisit that.
Must have come to you in a dream.
Okay.
Recursion?
Right.
That's where we
Reiteration.
took that was the Atari view.
Oh, okay.
But you can apply that to almost any form of AI.
And you can.
Well, let's use automated essay scoring. We train on 400, we start using it. Every time we score an essay, we put that back into the training set and we tweak all those probabilities. That's recursion.
Right, and which is what they're doing with cancer diagnostics today.
You want to tell us more about that sometime?
Probably could. Sure, done a lot of work on it.
Okay, we hit upon these issues, specifying the right model, training data bias, prejudice, and so forth. Didn't talk much about bad actors, and the major one. Medicine is a database where you put in a target molecule, it evaluates possible molecules that would have a similar effect, identifies those that would be fatal to human beings, fatal combinations, and out would come novel molecules with optimal properties. Pretty powerful database. They wrote this up, and these researchers said, that's an interesting concept. They went online and they pulled a database of molecules that had a database of known compounds that would be harmful to human beings. And they said, what if we decide to use this for evil purposes? And they stuck in nerve agent VX as their target molecule. And they said, give us all the molecules you can identify that would be like VX. VX was used to assassinate Kim Jong-un's brother, a little tiny little molecule. horrible effects. Well, they stuck this in, and sure enough, they came up with 40,000. Oops. I just lost the whole slide.
Go back up to.
They identified 40,000 molecules that would be fatal to human beings, many of which were known as bioagents, but others that were not. And the scary part of that was it was really easy to do. They used public data sets, and getting access to AI tools is trivial. OpenAI, which Elon Musk supports, it's a whole variety of free AI tools or low-cost AI tools.
You have 3 minutes.
I got 3 minutes.
Hey, Norm, you were talking earlier about using AI for photography. I'd be really curious if you could tell us a little more about that next week.
I can't tell you anything. I use programs that use AI.
Oh, okay.
So I don't know, I don't do anything except use the programs. It's what's behind that. And what they have fed to those, the programs, so that they can learn all kinds of different things about what's the sky, what's not the sky, and all that kind of stuff. But I'm not using AI. I'm asking it to isolate something, and it's using AI to do the isolation.
Oh, okay.
Example.
Well, I lost my last slide of the day. That was my last slide. So next week, we're going to talk about some scary applications and some failures of AI. What you'll see in the beginning is the theme of bias in the data. And then you'll see another theme of bad actors.
Deep fakes, things like that.
Deep fakes is one of them, yes. So that's my teaser for next week.
Sounds good.
Actually, we have 3 minutes. I'll pull up deep fakes.
I think it looks like 2 minutes, although you never know.
I may not be able to pull it up.
Oh, yeah, I know what you're looking at there. This is a social media application.
No audio. We lost the audio.
Well, that's because I'm not sharing.
Oh, let's back up.
Dangerous time.
Yeah, there you go. Now you can see it, right? Okay. Sorry, I was off my toes.
To say,
This is my
Now-
teaser next week.
You see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. That's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you. Stay woke, bitches.
It should be clear that the image on the left was computer generated entirely.
Yeah, yeah.
So
And that is scary, because no longer seeing is no longer believing, right?
that's right. Excellent. See you guys next week.
Thank you very much. Bye, everybody.